Hello there and welcome to this very exciting first video for cinematic lighting in Houdini. I'm Nick Chamberlain and I'm so happy you're here. I'm so happy you are taking this course. It's one I'm really excited to share with everyone. I think there's a lot of good stuff in it. So let's go ahead and hop right in and take a look at what we will be learning throughout this course. We'll just go through a quick overview before we dive into anything too deep. So when creating this course, I had three main goals at the outset. I wanted to show how to approach lighting a scene from a creative and cinematic perspective. What does it mean to light a scene cinematically? How do we compare it to when you are filming on set and they are lighting their scenes there? It needs to be both realistic, but also aesthetically pleasing. And that is often a difficult balance to get. So we'll talk about what that looks like. And then our second goal is understanding the technical process for lighting the scene within the context of a photorealistic visual effects pipeline. What does it look like when you have footage that you need to match the lighting to, but you don't have an HDR? What happens when you have an HDR, but it's not working correctly? When can I cheat my lighting, and when do I need to be bound by what the plate looks like? We're going to go over kind of how to approach these different types of visual effect shots. And then our third and final main goal will be to understand USD, Universal Scene Description. I'm a big believer that USD is the future in 3D. Most of the big visual effects studios are doing a lot of research into how to incorporate USD into their pipelines. And I think it's really a good time to start learning it, start understanding exactly what USD is and how it operates, because it is quite different than working just in standard 3D. A lot of the terminology overlaps but means different things. If you've ever looked up any of the documentation, you'll find that it's often very technical and hard to understand. And so we're going to be looking at USD through a practical standpoint. We're going to go through what I think are the most confusing concepts in USD and make it very clear what they're used for, why they're important, so that you can know when to implement one USD concept over the other. And we are going to be learning all three of these main goals through Solaris in Houdini. Solaris is the most advanced USD authoring tool that is publicly available. And I think Solaris is a ton of fun to use. There's lots of cool tools in there to kind of help your lighting workflow. And something I do want to stress is that while learning Solaris is certainly important and is a huge focus of the course, I do want to stress that at the end of the day, Solaris is a tool, and understanding the underlying concepts of these three main goals is much more important to me than understanding Solaris. And that's not to say we're not going to learn Solaris and understand it by the end of this course. We certainly will. But knowing these three main concepts will take you so much further than knowing Solaris ever could. Solaris is a tool, and we will learn how to use that tool and press the buttons. But these three main goals are really more about the why are we pressing this button? Why are we approaching it this way? And to me, that is just so important. So there will be a heavy emphasis on why we are doing what we are doing within Solaris. And so we'll hop in now to a weekly breakdown and just kind of look at the 8 weeks of this course. So in week 1, we are hopping in straight away to talk about lighting. We are going to do an intro to Solaris and USD basics. What is it? Why is it beneficial? We'll learn some theory and cinematic lighting principles as we start to light our very first scene. I wanted to start with lighting because a lot of courses talking about USD, start with the kind of boring technical basics. They talk about the asset creation, they talk about layout creation, and it's not until the very end of the course where you can actually start making things look good. So I want to start there. I want to start from the lighting standpoint so that anything we're making throughout this course, you immediately know, okay, now I can take this, light it, and make it look really nice. I think it'll be more interesting to follow along that way. So that is why we are starting off at lighting. And then in week 2, we are going to go to the foundational building blocks of USD in basic assets. We're going to learn how to create optimized and efficient USD assets. We're going to talk about color space management, USD layering, composition arcs, and more. And this is really going to give us a nice foundational knowledge of how USD works. Then in week 3, we are going to expand on our week 2 knowledge and use it to customize the component builder to suit our needs. And we are also going to learn how to procedurally create our own asset library and materials. Then in week 4, we are going to dive into shot layout. This is going to be kind of part 1 of our big CG shot. We're going to look at laying out that large scene with Solaris tools and instancing workflows. And we're going to look at how to look dev many lighting setups quickly. Then in week 5, we are going to continue working on that same shot. We are going to add our finishing touches to our lighting, to our layout, and then we are going to add effects to our shot and do some compositing. Then in week 6, we are pivoting back into lighting, and now we are going to start talking about something a little bit more plate related. Our lighting topic will talk about the technical process to correctly light when you have footage with HDRs. We're going to talk about spatial lighting concepts and what you can do really when you have everything you need to properly light a shot to footage. Then in week 7, we're going to take a look at the not ideal scenario. What does it look like when we don't have an HDR? How should we approach our lighting setup without any on-set photography help? And then finally, in week 8, we are going to take a look at sequence lighting. When it comes to lighting our spaceship sequence, how does that work when we're an individual artist versus a team of artists? How can we effectively collaborate in USD? How do we take maximum advantage out of this very flexible workflow? How can we essentially work on 5 to 100 shots at the same time? So we're going to take a closer look at that in week 8. So that is what it looks like for our weekly breakdown. And like I said, I'm really excited to show you guys what we have in store. And this course also comes with a few assets for you guys to use that are very exciting, because one of the big problems I had when taking lighting courses myself in the past is you're not really able to follow along because they don't have the rights to distribute the assets. But in this course, we do. We have 2 beautiful hero ship assets that you guys will be able to receive and use. And so those will be a ton of fun to light. We also have a pack of untextured buildings and sci-fi prop dressings that will take a look at procedurally shading for like midground background usage. And so those are really nice. We should have everything you need to build a really cool scene in 3D. The only thing that I'm not able to distribute is the close-up set dressing elements. I use some big, medium, small kits to do that, which I will show you right here. It's a really good pack. I unfortunately can't redistribute this, but like I said, these were for set dressing elements and for additional flavor. You don't need to purchase this to follow along to the course, but it is a really good pack and it adds some nice hero quality elements that look great in the foreground. And we're also including around 5 to 7 pieces of footage that was shot on an Ari Alexa so that we can practice lighting with footage that was done with a professional cinema camera. And so I'm very excited about that as well. Let's go ahead and move on and dive into more specifics about what we're going to learn in week 1 in our next video. Thank you so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we're going to dive into everything we can expect to learn in week 1. So let's go ahead and get started. So the very first thing that we are going to talk about are the benefits of USD and Solaris. Why is it important to learn, and how can our lighting workflows benefit? Then we will dive into basic USD terminology. We're going to learn the foundational building blocks that are required for understanding USD. And then we will continue learning about that terminology by building a very basic USD scene. We'll be able to see how it's structured within Solaris, and we'll be able to bring in some really nice provided assets to start playing around with our lighting. And then we'll also look at how we can load in our own geo and materials, and we will also learn how to assign those materials to our mesh through a couple different methods and talk about the pros and cons of each type of assignment. Then we'll start to dive into cinematic lighting principles. This is a look at theory of how films are lit and achieve their cinematic looks through motivated lighting. We're going to talk about how to make it aesthetically pleasing and dive into all of those fun details. And then we will hop into Solaris, look at the lighting tools that we have in our tool belt in 3D to accomplish those cinematic lighting principles. And then we will go ahead and start to light based off of a story. We're going to look at using reference and our tools to create an image that satisfies our three primary lighting goals. And then finally, once that is all done, we are going to take a look at rendering our image very quickly, matching our color space in Nuke, and submitting our first assignment. So that is what we have in week 1. I'm very excited to get to it. So let's go ahead, move on, and start talking about the benefits of USD in our next video. Thanks so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we're going to talk about the benefits of USD and Solaris and why we should use them. But before we can talk about the benefits of USD, we need to understand exactly what it is. So what is USD? USD stands for Universal Scene Description. The technical definition of it is USD is a comprehensive framework for storing complex 3D data in a single file format. A perhaps simpler explanation would be USD is a file format and a workflow that stores 3D scenes. And one of the big advantages of USD files is that they are universal, meaning that USD 3D scenes can be accurately loaded by most professional visual effects software. Almost all of the big players in the VFX software game have either implemented USD or they are in the process of implementing USD support. So exactly what 3D data can USD files store? USD can store geometry, geometry attributes, materials, animation, lighting, cameras, render settings, instances, and so much more. In short, it can store everything that you need for a 3D scene. It accurately retains all of your scene information. With USD, we could accurately load the exact same 3D scene in Maya, Houdini, Blender, or even Nuke for compositing. So just by defining USD, we have already exposed a major benefit. USD can accurately display its 3D data in most, if not all, professional VFX software. Imagine being able to send an asset from Maya to Houdini or from Blender to Maya without needing to worry about recreating materials, shaders, or your instancing setups. If you wanted to, you could even include scratch lighting that was done in your look development renders and then easily turn it off. USD allows a less painful workflow when it comes to sharing 3D data between our software. But USD is so much more than just a file format. USD is also a pipeline. It is a new way of working within itself that has many inherent benefits. The USD pipeline allows for teams to easily collaborate on shots and sequences without needing a massive VFX pipeline development team. Multiple departments can collaborate, share data, and update assets without interfering with one another. The USD pipeline allows for individual sections of a 3D scene to be automatically updated across a shot or a sequence. We can easily push an asset update across a large sequence of shots without needing to hop into every single project file and make an update. The USD pipeline also allows all of our 3D scene data to be constantly exposed and ready for modification. And we can also selectively control what updates we receive to our shot through opinions. It isn't like Maya referencing where we are appending files together. We can use stronger and weaker USD files to selectively load edits for specific shots. USD is also unlike Maya referencing in the sense where USD isn't really a black box. With USD, all of the data is exposed all of the time, and we can edit any aspect of our 3D scene that we have loaded without needing to open up separate files. We'll go through more examples of how the USD pipeline is beneficial later in the course, but these are the three broad strokes massive advantages when it comes to working with the USD pipeline. And another advantage of USD is that it is very efficient. USD can confidently handle complex 3D scenes and accurately display its data. USD file sizes are small thanks to its layering workflow. There is very little duplication of data that's required. The only data that is written down are your changes because of how USD works in layers. We'll talk about this more in detail in a later video, so don't worry if that is a little confusing for right now. Another advantage is that USD can talk directly to render engines, and this is a big efficiency gain for big sequences. So, USD is more than just storing 3D data, it can communicate directly to render engines. Traditionally, when you're rendering, visual effects software needs to translate a 3D scene to your renderer of choice. Let's take Mantra for an example. When we create a 3D scene in Houdini and need to render it, we can't directly render from our 3D scene. The data in our 3D scene needs to be converted into a format that our renderer understands. In Mantra, this format is a .ifd file. This conversion file is our scene description. It describes the 3D scene in a way that Mantra can understand and render from. Most, if not every, render engine has some sort of intermediary format that the 3D scene must be converted to in order to render. They all need different scene descriptions. Mantra has IFDs, RenderMan has ribs, V-Ray has VR scenes, and Arnold has the strangely named ASS file. Converting your scene into these scene descriptions takes time, and the larger your scene is, the slower this conversion process becomes, which makes our time to first pixel slower and slower. Now let's go to USD, Universal Scene Description. USD promises to be able to communicate directly with your render engine of choice, speeding up our time to first pixel because our USD file is already a scene description itself. The USD file can directly communicate to the render engine and skip that scene translation time. And that's also beneficial because if you've ever written out IFDs or ASS files, you know that they can become very heavy and be potentially several gigabytes per frame. And that data gets very large very fast, and being able to directly render from a .usd file has a lot of inherent efficiencies, not only in time to first pixel, but also in storage. So these are the benefits and efficiencies that we can see with USD. But we have even more benefits because USD is very asset friendly. This ties in a little bit with how USD is universal, and we won't have to recreate assets and materials when going from program to program anymore. But beyond this, USD allows us to store multiple variants of the same asset in a single USD file. We can have different materials, different geometries, different levels of detail. We can have proxy geo that can be displayed when we're in OpenGL view and then automatically switch to high res when going to render. And we can also use the concept of payloading our assets to avoid loading them in memory until we need it. This is another concept that we'll go over in week 2 and 3 when it comes to building our assets. So there we have it, our 4 major benefits of a USD pipeline. USD can accurately display 3D data in most professional visual effects software. USD is a pipeline that allows for easier collaboration between artists, as well as efficiently pushing updates across a sequence of shots. USD is very efficient and handles complex scenes well, and USD is very asset friendly. And if these benefits haven't really convinced you that USD is worth learning, I have one more reason to try and win you over. USD is promising to be the new standard for 3D collaboration and work. And in my opinion, USD is the future for assembling and rendering 3D scenes in the visual effects industry. Almost all of the major VFX houses are heavily investing in the implementation of USD in their pipelines. If you're aiming to work in visual effects professionally, having a knowledge of USD is only going to be beneficial as the industry continues to adopt USD more and more. I anticipate that in the future, an artist not knowing how to use USD would be like having a compositor who doesn't know how to use EXRs. It's a format that has such great potential for increased efficiency and optimization that it is simply too important to ignore, in my opinion. Throughout this class, we'll learn the specifics of how to use the many benefits of USD within Houdini Solaris. Solaris is the best USD authoring tool that is publicly available, and it is able to take advantage of all of these USD benefits we have listed. In addition to being a fully USD based lighting, assembling, and rendering suite, Solaris also has many quality of life tools that will help us light faster and more efficiently. So let's go ahead and hop into Houdini in our next video and start learning the basics of USD and Solaris. Thank you so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we're going to start taking a look at how Houdini uses USD in Solaris. So let's go ahead, hop right in, and make our first basic scene. So we have Houdini open here. Let's go ahead and change to our Solaris view. We're going to start off there for now. And also just a quick note, I have a few screen overlays. So if I start clicking, you'll know orange is left click, yellow is middle click, blue is right click. I have this drawer here that, it'll just allow me to highlight some things. And then I will also have a bit of a keyboard shortcut here at the bottom right. So if I do anything, you will know what I'm typing in. So just wanted to let you know that is going to be happening. All right, so let's go ahead and start bringing in some USD into our Solaris view here. And so in order to do that, I am going to create an asset reference node. And so we'll drop that in, and we'll see when we've created this asset reference node, our geometry spreadsheet has changed here. It has changed into the scene graph tree. As of Houdini 20, the geometry spreadsheet is intelligent and knows when we are in USD land here in our stage context, and will switch from the normal geometry spreadsheet that we know and love into this scene graph path. And the scene graph is going to show us everything that we have loaded up in USD on the currently selected node. But we don't have anything loaded in here, so let's go ahead and use our asset reference to bring in a USD asset. So referencing is one of two major ways that we load USD within a scene. Referencing basically means I am going to link to another USD file and bring in whatever the contents are. It's a shortcut pointing to another USD file. And this makes it very, very good for loading in assets. There are other nuances that we'll go into in a later video, but for now, know that referencing is the best way to load in an asset when we are starting to assemble our scene and bring in our individual components. So let's go ahead and click here to browse and find our USD asset. So I'm here with the folder structure that was included in the class. Like I've been saying, USD requires structure, and so it's very important that we try to follow the standards that are set within this folder structure. So we have an assets folder, V for vehicles. We'll go to Bomber and grab the publish here, and we will load our Bomber in. And now we have a Bomber loaded into our scene. We can turn off this view right here, and we can just unclick, lock selection, click away. So we have our Bomber loaded, and we can see our scene graph tree has now populated. We see we have this asset reference 1 loaded, and if we click this plus drop down, we can see there are additional folders. We have geometry, and then we actually have proxy geometry, which we can see here, and we also have render geometry. So this scene graph tree represents all of the data currently contained by the USD in our selected node. And Houdini also makes it very easy for us to inspect what our active USD looks like. What is this reference doing from a code standpoint? We can actually dive in and look at it. If we right click, we can go into LOP actions and say inspect active layer. And this is actually going to pop up the code that is running and generating our USD scene. So you can see the USD file is made of a couple default settings. We have our frames per second, the scale, time code, and then we can actually see the reference that we're loading in. There's not any geometry data in here. All we are doing is saying, hey, let's load in this USD file and let's put it in this location. This is just the transform that's saying put this at the origin, and so we're not currently moving it around. But this view allows us to see the actual code of our USD scene, and we can see the shortcut to that reference we made earlier. We don't need to know the specifics of every little bit and piece within here, but if you want to, we're able to dive in and kind of see what is going on under the hood in Solaris with our USD scene. And so if someone were to update the contents of this bomber.usd asset, we wouldn't have to load it in. We would automatically get that data pulled into our scene because we're just loading whatever is contained in this file. If you update it, this will automatically update. So I think that's something that is important to keep in mind and point out as we continue looking at USD. So what exactly are we looking at in our scene graph here? What do each of these lines represent? Well, each of these items are what USD considers to be a primitive. Primitives are the basic building blocks of USD. They are containers for 3D data. And this is often confusing because typically when we talk about primitives in Houdini, we are thinking of primitive attributes, we're thinking of actual polygons and mesh, but that is not what primitives are in USD. Primitives are a container for any type of 3D data. We can see if we expand over here, we have different types of primitive. We have mesh primitives. These contain our actual geometry. We have transform primitives. These behave like null objects, and if we were to move this transform primitive, everything underneath it would move as well. We have material primitives, and within our material primitives, we have shader primitives, and we have node graphs that have more shaders within it. Every single thing in our scene graph tree is a primitive. And here we have a scope primitive. Scope primitives you couldn't transform or move around, but they can store attributes that you can use later when constructing your USD scene. They are also often used as organizational folders, and it's just a nice grouping to put other primitives underneath. That's kind of how we're using it here. Primitive types define what kind of data is stored within this primitive. If we want to see a complete list of primitive types, we can quickly make a primitive node. And we can see here we have the primitive type. And if we just click this drop down, we can see all the different types of data that we can store in USD. And you could theoretically make an entire scene just by defining primitive types and setting their attributes. We won't be doing that because doing it with nodes is much faster and more efficient. But if you wanted to, you could. The most common primitive types have icons that are associated with them. So we know at a glance, these are all meshes, these are scopes, this is materials, and we'll see that as we continue to make more and more different primitive types. They have identifying icons that you can just quickly see what type of primitive we are dealing with. So all primitives need to have a name. We can see that the name of this primitive is geo. The name of this primitive is proxy. The name of this primitive is asset reference 1. And this is actually getting defined by our parameter right here. When we reference in a USD file, it asks us to rename the top level primitive. In this case, it is the asset reference 1. It is replacing the original primitive name that was here. So if we were to change this asset reference to bomber, since this is taking the name of the node, we can see our scene graph tree update, and now we have a bomber as our top primitive. And primitives can have the exact same name. I could name this glass in all caps. And once I expand this, we can see I still have this top level primitive named glass, and we also have this child primitive, which is also named glass. It is more than fine to have primitives that contain the same name. But primitives cannot contain the same namespace. But what is a namespace, you may ask? A namespace is the path of primitives that identify a primitive in the USD hierarchy. The namespace is our unique identifier of a given primitive. Namespaces are how we select, edit, and layer objects in USD, and that is why we can't have duplicate namespaces. So as a quick example, what would the namespace be of the energy engine? Let's change this back to Bomber just so it's a little bit clearer. All right, so our energy engine namespace would be Bomber / geo / proxy / energy engine. And that is because it is the entire hierarchy of prims leading up to that primitive. So let's go ahead and see a quick example of how namespaces are used. So we can make a transform node in here and just connect that. We'll go ahead and take a look at it. And in order to select our energy engine, we can drag and drop the primitive into this primitives tab. This tells our transform node what we should be moving. If I give ourselves a little bit of room here, we can see we can now start moving around the energy engines. But if we were to update the namespace of our bomber, perhaps we put it in a parent primitive named vehicle, we can see that our energy engines snap back into place because the transform is no longer affecting the correct primitive. The correct primitive now needs V in front of it for vehicle. So if we were to update that, now our energy engines can move again. This is something that's very important to understand with working in USD. It's important to be very organized from the start because paths are not necessarily dynamically linked like the rest of Houdini. If you were to update this namespace, this transform does not automatically update as well. So it is of the utmost importance to make sure you are organized from the start when working with USD. So let's go ahead and apply this transform to our entire bomber. So we can do that pretty easily by dragging and dropping from our scene graph, or if we wanted to, we could also just delete the file path that we have here, and that will move our bomber. So, we can move him around a little bit. Maybe we can see where the ground is. And I want to take this as an opportunity to show you something that really frustrated me when I was first learning Solaris, because I didn't entirely understand the importance of unique namespaces. Now, let's say we wanted 2 bombers. If this was within SOP land, you could very easily make a merge. And we'll put this bomber here, and we'll say we want this bomber to kind of stay put. So we'll take a look at our merge, and we will connect the bomber. Well, what just happened? Our bomber moved to the origin, but I want both bombers to appear. That is because they both take up the exact same namespace. So all of the attributes from this bomber, since it's on our right input, are overriding the attributes of the bomber on the left. And that is because they have the exact same namespace. And we are creating a layering operation within USD. USD thinks that we are currently trying to update the properties of a singular asset instead of what we're really trying to do, which is to create 2 distinct assets. We're actually forming a composition arc, which is how USD merges and combines with itself, to put it simply. We're going to talk about composition arcs more in week 2, but for now, know that if we have 2 objects with the same namespace and we merge them together, they're going to try to overwrite each other, not create 2 distinct assets. If we wanted to have 2 bombers, we would need unique namespaces. And so we could copy and paste this bomber, throw it in here, and now we see we have our 2 bombers because they are unique namespaces. And they are unique because since nodes can't have the same name, this is vehicle bomber 1, where this is just vehicle bomber. So now that we have 2 bombers loaded into our scene graph path here, maybe we can just organize this a little. We can call this bomber landed, something like that. Let's go ahead and talk about these 4 symbols here in our scene graph and what they mean. The first one is pretty self-explanatory. This is if we are able to select the primitives. And so if we go in here, we can no longer select the primitives because this is off. And we can see this goes dark and there's a little bit of a red dot next to it. But once we enable that, we can go ahead and start selecting the primitives that we have in here. So nice and self-explanatory, that one. The star represents soloing a primitive. So we could just look at this bomber. We could just look at our landed bomber. If we wanted to expand this, perhaps, we could look at just the engines on this landed bomber, and we can see here there is a red circle, and this indicates that there is a viewport override. Viewport overrides only affect our viewport. If we were to try and render this out, it would not see our solo. This is just for debugging and troubleshooting. All of our viewport overrides only happen in our viewport and not in a final render to disk. So these next two are interesting symbols. They are the eyeball and this power symbol. And these are two different ways that we can turn primitives off. If we click the eyeball, it will make this primitive invisible. If we click this power symbol, it will make this primitive deactivated. And there is a difference between the two of these. And we can also see that familiar red circle next to them, letting us know that it is a viewport override. So what is the difference between these two? Well, the easier way to kind of explain it is to do it for real in a way that is not a viewport override. So we can actually clear this with a quick command. We can go to this drop down here and say clear all viewport overrides, and that'll just get us back to what this will look like if we were rendering. So let's go ahead and make this invisible and deactivate this bomber for real. So in order to do that, we need to make a prune node. So we'll go ahead, drop our prune in here. And the prune node is looking for a target primitive right in here to make invisible. So let's go ahead, drag and drop our flying bomber, and we have now made our bomber invisible. And we can see this eyeball has been turned off without the red dot next to it. And for our bomber landed, let's deactivate it. So we'll go ahead and just copy and paste this prune. And within this primitive path, we can just do an underscore and it should try to autofill. We'll select bomber landed and that will work. We can change this to deactivate. All right, so we have an invisible primitive and a deactivated primitive. What is the difference between these? With invisible primitives, their descendants still exist and are processed by USD, but they are not shown in the viewport or rendered. And when I say they're processed, I don't necessarily mean that it's loading in all of our geometry, but it is going through and cataloging what primitives we have in here. And it does this in case they're being used elsewhere in your scene, so it knows to fully load them. So there is a little bit of processing compute time when it comes to hidden primitives. On the other hand, our deactivated primitives and their children are not processed by USD or LOP nodes. You see, there is no way we can expand our deactivated bomber landed. If we look at the amount of primitive descendants, we can see there's only one here. There's just this primitive, where within this bomber, even though it's hidden, we still have 151 child primitives within this section. So this is faster to compute because Solaris is not looking through these child primitives for any information. We're telling Houdini that there is nothing in this primitive branch that is active, so don't even bother. The disadvantage to deactivating primitives is, like we saw, all the child primitives are inaccessible. So if we are trying to use a child primitive elsewhere in the scene, we won't be able to. It's not there unless we were to reactivate the parent primitive. This is especially prudent for materials. Let's just bring in a quick example right here. I have this purple material that is applied to this cube. It's a very advanced Solaris scene. If I were to make the material hidden right here, we can see we still have our purple shader. But if I were to deactivate the material, our cube can no longer find the material that's assigned to it, and it gets a generic flat gray shader. So now let's go ahead, dive back into our scene. We will delete these and let's continue talking about primitives, or more specifically, primitive properties. Like we said earlier, all primitives have a primitive type that define what kind of data that primitive contains. The actual data for each primitive type is stored in its properties. And to see its properties, you simply click on a primitive and they will populate in here. Let's go ahead and full screen this for a second. So we can currently see all of the properties for our engine's primitive. And properties are made up of two things. They're made up of attributes and relationships. Attributes will be very familiar to us if you have worked with Houdini at all. They just have a little bit of some funny naming, as all things in USD does. We have the points attribute right here. This is our P position. We have our normals, our N. We have our UV maps, which is an ST here. We can also notice that this attribute has a primvars prefix. Primvars are custom attributes that typically are used to help drive shader and renderer properties. We'll take a closer look at primvars in week 3, but UVs currently live within this primvar, this custom attribute, and we can actually see the attribute like a very poorly arranged geometry spreadsheet in Houdini. It's not nearly as nice to look at, but we can see what each of these vertices has in terms of a UV attribute. And the same for points. We can see the actual position data of our points in here. We can also see our normals. It's all right that these aren't as clear in Solaris because we are not really making geometry in LOPS. LOPS is meant for assembling, lighting, and rendering. So I'm not bothered too much by this being harder to read than the normal geometry spreadsheet that you would get in SOPs. So we have our attributes within here, and the other component of a primitive property is relationships. And so we have in this material binding here, we can actually see what material this mesh primitive is bound to. So we can see it's in vehicle, bomber, material, engines. So we know that there is a relationship between these two primitives here. And that is what relationship properties are for. It's for showing how this primitive is associated with other primitives. And relationships will always be read in this properties view. And a quick side note, there is an easier way to see what material a primitive is assigned to at a glance. In this dropdown, we have a variety of different properties that we can look at, and we can actually click this material dropdown. And now if we give ourselves a little bit of room here, we can actually see the name of the material that this is linked to. You do need to be careful though, because if there is another glass elsewhere in our scene, it could potentially be linked to that because this doesn't show the full namespace. If you ever want to know, you can dive in and see the namespace of the material here. And another relationship that I think is interesting that is worth showing is on this render scope right here, we can actually see the proxy primitive. This proxy geo right here is the proxy for the render geometry. And that is also a dropdown that we can see here, the proxy path. It's really annoying how this always snaps back, but we can see all of these have their proxy path associated right here. We'll take a look at proxy setup in close detail in week 3, don't you worry. But for now, let's go ahead and see the proxy in action in our viewport. So what we've been looking at in the viewport this whole time is our proxy geo. If we look close, it's kind of not the best, there's kind of some weird indents in here. And that is because in OpenGL view, Houdini knows to use our proxy mesh. If we wanted to see the final render mesh, we can control that in here. We can see that currently we have our proxy on, but let's change this to final render. Solaris will think for a second, and now we have